All right. A 25 liter balloon is filled with N2O at 25 degrees C and 800 torr. How many molecules of N2O are in the balloon? All right. Key thing there, molecules. Key word. Anytime you have moles, mass, number of particles, any of that, you know that somewhere in there you're going to have PV equals nRT. Somewhere in there that's going to exist. Okay? So let's go ahead and sort through what we know. What do we know? Well, 25 liters. What's liters? Oh, that's volume. So we got that. It's filled with N2O at 25 degrees C. Oh, that's a temperature. We know that. And 800 torr. What's that? That's a pressure. We know pressure. We also know R, but so we're going to solve for N because we need to figure out how many molecules. But before we can do that, remember when we use PV equals nRT that R has this value of 0.0821 liter atmospheres per mole Kelvin. Okay. So that means our pressure has to be in atmospheres, volume in liters, temperature in kelvins, like always. So what do we have? Well, let's write that down over here. Pressure is equal to 800 torr. Well, we need to convert that to atmospheres. So we know that there are 760 torr in one atmosphere. So we can say 800 torr, and then we know there are 760 torr in one atmosphere. So I do my handy candy calculator. 800 divided by 760, 1.05 atmospheres. All right, volume is 25 liters, and we don't know what N is. R we know is 0.0821. And T is equal to 25 plus 273. Remember, we're converting it into kelvins. All right, now we just put it all together and say, oh, let's rearrange this for N. Well, I'll put the numbers in, then we'll rearrange it. Pressure is 1.05 atmospheres. Volume is 25 liters. And we don't know. 0.0821 liter atmospheres per mole. Okay. Uh-oh, we're running out of room. Times, we'll just set it down here. T, which is 298 kelvins. Alright, so when we do this whole thing, we end up with N is equal to 1.05 atmospheres times 25 liters divided by R, 821, and the temperature. So, what does that equal to? Well, let's calculate it. We have, what do we have? 1.05 here times 25 divided by 0.0821 divided by 298 equals. So what is that? 1.073 moles. So good to, it looks like, what, couple, 3 6 figures, 1.07 moles of what gas is this? N2O? N2O. But, is it asking for moles? No, it's not asking for moles. It's asking for molecules. Well, we can do that conversion. Let's move this up a little bit, gives ourselves a little bit more room. Well, we can say, okay, we have 1.07 moles of N2O. And what's the relationship? Oh, we know that 1 mole of N2O contains how many particles? In this case, molecules. Avogadro's number. And that whole thing is equal to a large number. Let's plug it in. (1.07) times 6.02 EE23 equals 6.44 times 10 to the 23rd molecules N2O. Whew. There we have it.